we'll talk about how to write chemical formulas and how to balance equations if you've been given. Now, the first thing in writing a chemical formula if you've been given a weight equation is you need to know what we call a valency. A valence is just the combining power of an element. Okay? If you have got atoms which are in, say this is the periodic table like this. Should have mentioned this last time. If you have got an element in group 1, for example sodium, what's its valency? What will be its valency for sodium which is in group 1? Yes. So group 1 I've got a valence of 1. How about group 2? A valence of 2. And then group 3? A valence of 3. Okay, what example can I give Armenia? And then group 4? Valence of 4, good. And then group 5? 3, good. So this is 1, this is 2, this is 3, 4, 3, and then group 6, a valence of 2. Okay. And then group 7, valence of 1. So on the periodic table, somewhere just where aluminium is supposed to be somewhere down, a bit down here. So where it is, like, we are going to be able to cut to divide metals from non-metals. So what you can see on top here, these are non-metals. Now metals, their valence is going to be positive. Non-metals, it's negative. Yeah, so that is on their valence like that. Now when you're writing the formulas for compounds, make sure that you understand the valence because you really use it. Let's say we want to write a formula for magnesium chloride. That's the molecule. Magnesium chloride. By the way, I've not talked about these compounds which are here. Here. These are transitional. Their valence changes, so it will depend with the molecule. Even when you are writing the name of the compound, the name will tell you the valency because those are transition metals. Okay, say we want to write the formula for magnesium chloride. We know magnesium has a valence of 2 and then chloride has a valence of 1. So these numbers will be able to swap them. So it becomes magnesium. The one that is on chlorine will come down, and then chlorine, the 2 on magnesium will come down. But we don't show 1 when you're writing the formula, so this will just be like this. Is that okay? So that is how you write the formula, magnesium chloride. Let's say we wanted to talk about, say, aluminium oxide. Now for aluminium oxide, aluminium is in group 3, it has a valence of 3. Oxygen is in group 2, it has a valence of 2. So when these are forming a compound, the numbers will be able to swap. The aluminum will carry a 2, and then oxygen will carry a 3. Now when you want to write this as a chemical formula, you need to know there are some elements which exist as diatomic. The meaning of diatomic is that they will exist with a 2 down. Nitrogen, oxygen, chlorine, a fluorine, hydrogen. These ones here, they exist as diatomic gases. Even bromine, you always see them with a 2 down. So even when you're writing a chemical reaction, make sure that if they mentioned oxygen, you should have a 2 down. So for example, if magnesium reacted with oxygen, you are going to say magnesium plus oxygen. Now oxygen should always have a 2 down here. And remember, this will produce magnesium chloride, and we've said magnesium oxide, and we've said it's going to be like this. But this equation is not balanced. You have to balance it. The first thing is you're supposed to balance other atoms before balancing oxygen. So look at magnesium, there are 2. So put a 2 in front here. When balancing, you always put a number in front. And then oxygens, how many are they? There are 3 of them. Okay, there are 3, but here you only have 2 oxygens. So you can't balance that. So I'm going to remove the 2 from the magnesium. Then what am I going to do? I'm going to bring a 3 here. If I bring a 3 here, this makes the oxygens to be 6. So I'm also going to put a 2 here. Please don't fit a 2 here. Always put it in front. This will make 2 times 3, that makes 6 oxygens. And when I put that 2, it will mean 2 times 2, that is 4. We have got 4 magnesium. So I'm going to put a 4 here. So this is the balanced equation. You can also include the state symbols. Magnesium, metals are solids. Oxygen is a gas. Magnesium oxide is going to be, it can be an aqueous or a solid, but this is going to be like a solid. Okay, so that is it. Let's say you want to write a formula for silver chloride. Now for silver, they are going to tell you, because it's a transition element, so they'll tell you the valency. Silver 1, let's say it's oxide, silver 1 oxide or silver oxide. The symbol for silver is Ag. This is going to react with the oxygen. Now silver, they've told us the valence is 1, oxygen the valence of 2. These 2 numbers are going to swap, so therefore it becomes Ag with a 2 and then oxygen. To be able to balance this, you can see oxygen is not balanced. I'm going to put a 2 in front here to be able to balance oxygen. If I put a 2 there, it means that the silver has become 4, so I now put a 4 here. So that is how we are able to balance this formula. We can also write the state symbols. Silver is in group 1, silver is a metal, that's a solid. Oxygen is a gas. Silver oxide can be an aqueous, can be a solid, depending with where the reaction is happening. If the reaction is happening in water, it is going to be in aqueous. Now there are some other compounds you need to know the valence for, because you can't get on the periodic table. And where do you know the valence from? You know the valence because these ones are known as radicals. Radicals are a group of atoms which have the same valency. And the first one is a sulfate, SO4. This is a sulfate. It has got a valence of 2. Okay. What's the name? sulfate. It's different from a sulfide because for a sulfide it's going to be S